Okay, welcome back. I'm just gonna explain a bit about the homography and why we want to use it. It's basically because we want the display to look the best when using this augmented reality, which is a demand or requirement from our final problem statement. And either way, if we're gonna use either color tracking or fiducials, like this one, we wanted to follow the scaling and the rotation of the tracking of the fiducial or color tracking. So we found a picture here where someone has used the homography, and as you can see, he just has this background where he has inserted a picture, and whenever he turns the picture, whenever he turns the book, the picture he inserted is following the scale of this book of his. So that's what we want to do, and yeah, we haven't really gotten around to it yet, so that is why we just showed you the color tracking that will enable it. As for now, we are going to explain some of the code we've been using for the color tracking at least, and I think Andreas will start with this one.
Yeah, well, we're in the header file right now, and we've been building this up from the template of the video grabber, using a lot of the basics from that Open Frameworks example. So naturally, there's a lot of the same setups there. You know, all the basics, setting the height and the camera width, and and where to get the video feedback, of course. Now the more interesting aspect of this to us is well, first of all, of course, these open framework points. We've set 4, and as you can see here, each point is for each of the 4 colors on our lovely little test mouse pad here. And set up some counters for them here, where we get to that in just a bit. But the counters are used for the in order to figure out the center of the colors, as Jesper mentioned in his video. And yeah, setting up some variables as well as for the results for figuring out the colors
in the code.
In the code. And of course, we set in an OF image of the display that we made. And yeah, as mentioned, yeah, we're working. There's a bit of extra code in here in the program that's not really relevant at the moment, because this is still under development, and we really want to get the homography here in over it as well later. So if we go to the test tab for the setup, of course, when we have the window set up, prepared, and starts recording, grabs the frames, and store the the frame of each frame per second in an array with the allocation, so we can go in and investigate each pixel, as we'll be doing very soon here, in order to determine whether or not it has or does not have the color we're looking for, so we can track it. And do you want to start with the update?
Yeah, sure. So as for the update function, which runs every frame, the setup doesn't. It's just initializing, as you can see here. We have the update function where we grab our video frame, and if it is a new frame, then we go through each of the pixels. So here we have the height and the width, which means we go through every pixel, and then we have the 3 color channels. And well, what this is doing is actually just giving us the video output. So we have color image, which is the data loaded into our video texture down here. You can see color image again. It's the same as the pixels we're grabbing up here, which is vid grabber get pixels. So this is actually just a webcam right now. Yeah, nothing really fun happens in here. But as for the draw function, wait, I think we're just gonna go down a bit and return to the draw function actually, and the same with the key pressed function, because the interesting thing that enables all of this is actually the track rect, which is our tracking function, and it runs every frame as well. And here's the pose, or the points, OF points, that Andreas just told you, and the counters, which are being reset after each frame. And the reason why they have to be reset is because the position is added to the X position is added to this OF point variable, and then it has to be divided by the counter, as you can see down here. Here we added the X position to the pose X, the Y position to the pose Y, and then we increase the counter by 1 for each run through. And what this is used for, this is for the blue, red, yellow, green, and same down here. What it's used for is actually just division. So we have the pose X divided by n at what state it's in right now, and this is helping us to find the center of the colors. So it won't, if we didn't have this, it would just find the last one down here. So I don't know if this should be inverted, I think, so it will be down here in the color because it runs through, and we just want to find the center of it, so that is what this is enabling us to do. As for finding the colors themselves, we have defined the red, green, blue color channels, which is declared earlier in the update function, as well as in the header file. And here we have how we're looking for each of the colors. As you can see out here, we have blue, red, yellow, green, and what it is doing is saying that if our blue color is bigger than green plus 30, which is the intensity of the color, and blue is bigger than red plus 50, then it is setting result to 255, otherwise it's setting it to 0. So down here, if this one is true, then this one is true as well, right? And then it adds the position and adds the counter, as I just explained. And this is happening for all of the colors, so this is actually what tracks the color for us. As for the red one, it's of course the red ones that are bigger than the green and blue. As for the yellow one, it's a bit different, not much, but it since we are using red, green, blue colors, then we had to do something different for the yellow one. So the yellow one is actually red being bigger than blue plus 50, and green being bigger than blue plus 50, which gives us this yellow one. And the green one is the same as the other one, sort of. So I guess that's basically the track rect function, right?
Yeah.
So if you want to explain, you can start by the draw and the key pressed afterwards.
Yeah. Yeah. Well, we start up by using the inbuilt OF function of set color to be completely white, and then, well, draw a big big white box, and
which is also to get all of our colors for the pictures and video feed in the all intensity or all colors. If we had it in any other kind, for instance 255:00, which means red, then the video feed would be completely red.
Yeah. And what Adam?
Yeah, it's
That's
a
a Boolean,
conditional.
yeah.
It's just used for the presentation, right?
Yeah.
So when Adam is active, then
we have the circles.
Then we're using the track rect function.
Yeah.
Calling it every frame.
Yeah. And you were, you went over that. Could you take the? That was the track rect that you just went through.
Yeah, exactly. So it is called every time, which basically just means that every color is being tracked while Adam is active.
Yeah. Right. So after that, when it's run through the track rect. Then if C circle is true, which is set by the keybinds.
Yeah.
Here we go. Yep. Pressing V, enabling that. Then at the point of every center of these 4 colors, we'll use the OF circle function to draw a circle around it, as you could see in the movie when Jesper turned it on. As for naturally, not something meant to be happening in the final implementation of this, but something that's very helpful for us when debugging it, when starting working on it, because we know by drawing those circles we can see where our program tracks the different colors to be, and if it recognizes them where it's supposed to. So if you press V, then it will do this, right? Make all these the circles, and
also this one.
yeah, and further down here, and make the rectangle with the wide rectangle, or do we make it black for the movie?
Yeah, that's the wide one.
That's the wide, yeah. And it will do that using the begin shape function that Jesper mentioned in the movie. Drawing, so it looks like a rectangle, but it's not rectangle in the same sense as the OF rect function to draw a rectangle. It's 4 lines created that exist between the 4 points that we've made of every color, as you can see here, between the blue,
the blue one,
yeah, the blue, and the red, green, yellow point. So we have this wide rectangle. Oh, it's a fast scroll. And furthermore, inside this conditional, then if sorry,
it's conditional here.
Yeah.
For the picture,
yeah,
and that was just the display you were watching, which is basically just drawing the picture you saw in the video on pose 4.x and pose 4.y. Mine,
yeah, and that's our green.
Yeah,
right. Yeah.
And the last condition we should mention is the value rect, and it is something we developed with a lot of conditions in order to see when the display should be drawn, and it is done so by tracking the position of the different colors. Yeah,
because if we didn't have this on, then basically it would draw it as long as it's able to identify these 4 colors in whatever it's seeing, and that shouldn't be too difficult. But with this, it actually states states that how the colors are supposed to be arranged according to each other. It's a lot easier if we take the pad here and say that naturally you can see that as is in these conditionals as well, that the blue must have a lower X value and a lower Y value than yellow, and it must have the blue must have a lower Y value than red, and it must have a lower X value than green. So I believe you showed that in the video as well, didn't you? Yeah, that if you start twisting it, then changing these relations, then it won't show the picture or the rectangle.
Yeah. But then again, a lot of this code is primarily just drafts of our project in development, because some of these things might change, might not change, if and when we get the homography to work. Otherwise, we are having the backup plans, as for instance using the conditionals here, which works pretty well as well, but it doesn't give this